NASA unveiled pictures from a new space telescope capturing the deepest images of the universe anyone has ever seen.
August 18th, 2025. In a remote NASA control room, dozens of monitors flicker. Scientists hunched over their data streams, the ticking of the atomic clock echoing in the background. It was scheduled to be another routine session. The James Webb Space Telescope, inheritor of Hubble's legacy, turning its peerless optics toward a region of sky once dismissed as devoid of interest. Yet it is often from such quiet spaces that the cosmos sends its most unexpected messengers. On this unremarkable date, Webb's detectors captured a single dark anomaly, a feature that stood out stark against the mapped emptiness. The sky, so carefully scrutinized for decades, played a new card, presenting a signature that defied easy calculation or familiar explanation. Data were immediately checked and rechecked, algorithms verified, every system scoured for possible glitches. And yet, the anomaly persisted, a stubborn puzzle piece in the tapestry of deep space. NASA's well-rehearsed protocols leapt into action. The call was made, Red Alert. This was no routine calibration issue or data hiccup. Red Alert is reserved for phenomena that can overturn our fundamental assumptions, demanding urgent focus and cross-disciplinary expertise. Assets across the solar system shifted their gaze, each gathering precious data to shed light on the enigma. Today, this is where the world of science stands, at a threshold, confronted with a celestial event so singular that it has compelled even the most skeptical minds to consider previously unimagined possibilities. What exactly did Webb's optics detect, 124 light-years away? What kind of phenomenon lingers in the darkness, demanding the attention, not just of instruments and protocols, but of collective scientific scrutiny? Could these observations point towards life? Or are we simply seeing a process that, while strange, is dictated by as yet undiscovered laws of physics? A rendezvous with the unexpected. Attention now centers on a point well beyond the edge of the solar system, out further than most of humanity's dreams have wandered, where the light itself thins and the familiar markers of space begin to blur. The James Webb Space Telescope, in its detailed survey, identified compelling evidence for a planetary system circling a star 124 light-years distant, a system recorded in star charts as little more than a faint smudge. It wasn't just the presence of the planet that drew focus, however. An unusual feature in the planet's atmospheric data, a thick absorption band, raised urgent questions. This spectral signature could not be adequately accounted for by dust, ice, or stellar activity alone, the typical suspects in such investigations. Instead, it pointed towards the presence of chemical compounds previously considered most likely to result from biological activity. Specifically, the coexistence of methane and oxygen was measured in the planet's atmosphere. On Earth, the simultaneous abundance of these two gases is deeply linked with living processes, as geological or abiotic sources would not be expected to maintain them together for long. The detection, while not indisputable evidence of life, represents one of the strongest hints yet that this distant planet could harbor biologically relevant activity. Webb's instruments also picked up other details: a dynamic atmospheric spectrum including organic molecules, subtle heat signatures, and fluorescence, all consistent with a complex, possibly active, planetary environment. While these data don't offer a direct proof of life, their particular alignment is rare and has set the scientific discussion ablaze. Add to this the coincidence, the appearance, near this system, of a previously undetected dark mass. This object could not easily be categorized as a planet, moon, or natural material. Its presence, hovering at the limit of observation, distorted nearby starlight and resisted modeling with known astrophysical objects or processes. Astronomers remain cautious. They ask, is this a natural cosmic event, a stray body, a new kind of stellar remnant, or simply a phenomenon outside current understanding? And as the data accumulates, the mystery only deepens. If you want to keep following this unfolding mystery and be among the first to catch each new revelation from Webb, make sure to hit subscribe so you don't miss what comes next. Now, let's move on. Parsing the Anomaly. In the weeks following the event, NASA convened emergency scientific reviews, drawing on expertise ranging from exoplanet researchers to theoretical physicists. Most urgent among the findings was the nature of the anomaly, a dark mass that registered as both physically substantial and intensely elusive. Its gravitational lensing effect bent the surrounding starlight, but without the usual signature of known objects such as black holes or neutron stars. No event horizon was identified. No energetic radiation typical of compact objects was seen, and the surrounding matter appeared undisturbed. Technically, every step was documented. Data were pored over for possible instrumentation errors. None were found. This was not a ghost in the machine, but a real, measurable perturbation. Some compared the event to the 2017 observation of Oumuamua, the solar system's first known interstellar visitor, which had defied categorization. But the scale here was vastly greater, with Webb's resolution making it clear that this mass was neither a conventional comet nor asteroid, and was not emitting or reflecting the typical radiation of any known celestial body. In effect, it seemed almost to erase light itself. While initial hypotheses invoked black holes, the absence of associated high-energy signatures forced astronomers to broaden their search for explanations. The gravitational influence was subtle, but visible, as light bent in ways not predicted by models. At the same time, the potential biosignatures on the nearby planet lent urgency. Was there a relationship or just improbable coincidence? Science thrives on asking if anomalies herald new knowledge or simply errors in understanding. As of this moment, the anomaly at 124 light-years stands as a challenge to established theory, one with no easy answers. A tangle of evidence. Subsequent Webb observations extended the mystery into neighboring regions, including a fresh survey of the Bullet Cluster, a famous set of colliding galaxies. There, new images captured by Webb revealed a population of extremely faint objects undetectable by previous generations of telescopes. Some appeared as indistinct filamentary structures, massive but dim, potentially shaped by dark matter or unexplored cosmic processes. Crucially, among these ancient galaxy clusters, Webb's instruments identified additional dark anomalies, features too organized and geometrically regular to be dismissed as chance formations or dust clouds. The effect of gravitational lensing, where light is warped by massive objects, was also subtly but consistently offset, suggesting the interference of another, as yet unidentified, component. Detailed examination of earlier astronomical data brought to light faint, overlooked discrepancies stretching back decades. Only with Webb's newly available sensitivity and resolution did the significance of these noise signals start to emerge, painting a faint historical outline of similar, though much less pronounced, disruptions. The implication is not that this object suddenly appeared, but possibly that improved observation has at last made it visible, either by chance alignment or by the slow unveiling of processes long in motion. What matters most is that a pattern is discernible. Subtle distortions recurring over time, now freshly illuminated by Webb's successor's gaze. The language of shadows. Attention turned next to the anomaly's seemingly variable emissions. Webb's sensors, capable of measuring exceedingly faint fluctuations across the electromagnetic spectrum, registered intermittent pulses, a series of brief, periodic signals. While not resembling radio transmissions or natural pulsar emissions, their timing and mathematical structure did not appear obviously random. Analysts detected repeating patterns that mapped onto mathematical constants and harmonic intervals, a curious parallel to structures found in nature and mathematics alike. Although striking, caution dominates. Many natural processes can give rise to structured periodicity without requiring intentionality. Astrophysicists continue to debate whether these pulses are related to the mass's physical properties, internal vibrations, gravitational interactions, or something more. The phenomenon does not match known astrophysical sources, and the exact origin and nature of the signals remains undetermined by current science. Radio telescopes and space-based observatories have since tuned their instruments to the region, looking for similar patterns or correlating events elsewhere. Overlapping signals in unrelated data sets have been scrutinized, but as yet, none can be conclusively linked. Interpretations abound, ranging from natural but unknown cosmic mechanisms to more exotic possibilities. What is certain is that the phenomenon has propelled new collaborative efforts in data gathering and analysis, uniting observatories worldwide. The weight of discovery. The implications of Webb's findings have sent ripples not just through NASA, but across the entire scientific landscape. The observation of a planet's atmosphere bearing both methane and oxygen, combined with organic signatures, amounts to one of the most significant exoplanetary discoveries to date. While not confirmation of life, it is the kind of evidence long sought by the field of astrobiology, evidence strong enough to merit urgent investigation. The coincident detection of a massive, gravitationally active and light-absorbing feature only accelerates the need for answers. Debate remains as to whether these findings are causally connected or if their proximity in space and time is coincidence. Crucially, this mass interacts with its environment in measurable ways, warping starlight and causing deviations from expected stellar signatures. More puzzling still are the occasional bursts in the infrared, short, intense, and not attributable to known stellar activity such as flares or outbursts. As the worldwide network of monitoring stations, ground and space-based alike, focus in unison, the data pool grows, to be analyzed from every angle by planetary scientists, physicists, engineers, and specialists in disciplines yet to be named. Each new observation, each spectral analysis, only adds to the sense that a major discovery may be within reach. But for now, the phenomenon remains stable. No dramatic shift, no escalation, simply a presence, waiting for comprehension. Across the divide. Standard NASA protocols for such discoveries require not only data collection and analysis, but also coordination with international partners and, where appropriate, contingency planning for ongoing observation. The drift of the anomaly's apparent position, though subtle, has so far not been explained by ordinary orbital mechanics. No natural object, comet, asteroid, or rogue planet fits the observed movement, which appears purposeful only in its resistance to natural explanation. At this stage, the pulses detected correlate not to any recognized celestial events, but rather seem clustered in sync with observation intervals, fueling discussion about whether this is artifact or meaningful data. Still, scientists emphasize that observation bias and instrumentation schedules can produce misleading patterns. Military and civilian telescopes alike have redirected focus, expanding the spectrum of observations far beyond what was initially planned. Intelligence and defense analysts, typically including such anomalies in their sweeps for satellite debris or near-Earth objects, have found no indication of obvious threat or technology. The mass's behavior resists classification. Alongside this, the astrobiological implications of the neighboring planet grow more urgent. The presence of atmospheric biosignatures, methane and oxygen together, suggests an environment out of equilibrium, potentially maintained by biological processes. However, alternative geophysical processes, though rare, must also be considered. Thus, while the cosmic alignment of factors is striking, a life-friendly planet and a disruptive mass nearby, science continues to call for caution until more data can pierce the veil of probability. A cosmic tipping point. The global scientific community, now united in pursuit of resolution, recognizes that extraordinary claims require extraordinary evidence. The mere detection of a possible biosignature, regardless of nearby anomalies, changes the future trajectory of exoplanet exploration. It is a testament to modern instrumentation that such measurement is even possible, and underscores how rapidly our window onto the universe is enlarging. NASA's red alert in this context is not a signal of existential threat, but a formal acknowledgement of the singularity of the finding, a prompt to marshal resources and attention at the very edge of human understanding. Data are being embargoed for rigorous peer review. Teams from every continent are reviewing findings, and every new observation is cross-referenced with both historical and ongoing records to ensure that no clue is missed. As data accumulate, so do possibilities, some simple, some profound. Perhaps the dark mass is a previously unclassified type of matter, or perhaps our understanding of cosmic lensing and energy emission needs revision. Maybe the planetary signatures signal new kinds of geochemical processes, not life. But perhaps, if not from the extraordinary source, then from the process itself, new knowledge will emerge, reshaping the roadmap for the study of origins, life, and the fabric of the cosmos. The edge of knowing. In the months since the initial finding, news of the anomaly and its context has spread, stirring public interest and scientific excitement in equal measure. The pairing of a planet with rich atmospheric chemistry, suggestive of life, alongside an object that challenges the reach of current theory, has opened a new chapter in our quest to understand the universe. This is a moment both humbling and thrilling for science. The questions now being asked: is the mass a natural feature of cosmic evolution? Is it an unknown phase of matter or energy? Or, in the most speculative terms, is it a sign of processes or life far beyond our comprehension? Are the very questions that such telescopes were built to enable. There is, for now, no evidence that the anomaly is a signal in the commonly understood sense. While periodic pulses were observed, their repetition and structure have not been decoded as communication, and no threat or overt sign of intelligence has been identified. The data, however, does point to something complex, a phenomenon that resists extant classification, a puzzle inviting deeper inquiry. The Webb's success here is, above all, a reminder of the fundamental truth. Only by asking bold questions and building ever more sensitive tools do we become capable of glimpsing the universe as it truly is. Some theorists speculate about quantum effects, cosmic shadows, or hidden mass energy configurations. Others prefer to await more data before extrapolating. What all agree on is this: our understanding has reached a precipice, and the only responsible path is to continue seeking, measuring, and debating, aware that every new discovery brings with it as many new questions as answers. NASA's red alert, then, is less an alarm and more an invitation, a call to look again, with open eyes and sharpened senses, at a universe that still holds unknowns at every turn. The planet continues to orbit its star, atmosphere glowing with tantalizing hints. The mass, for now unnamed, persists in the darkness, silently warping the space around it as human curiosity expands to meet the scale of the unknown. As the scientific community carefully moves forward, reviewing and contesting every claim, the process itself of patient questioning, skeptical investigation, and collaborative pursuit of truth remains the bedrock of discovery. The anomaly endures, a monument to the limits of current knowledge. The atmosphere of the distant planet stands as a beacon in the dark. The cosmos stretches out, waiting. And perhaps that is the most important lesson of all. The universe always has another riddle to pose, just when we think we've started to understand its language. If you want to follow this unfolding story, stay curious and keep looking up. The answers, when they come, will change more than just astronomy. They may reshape what it means to ask the oldest question: what's out there beyond the known? Until next time, as Webb and the world's instruments scan the heavens, remember, the future of discovery is only ever a question away.